Hello and welcome to Module 2a on matrices. This module will be on multiplication of matrices. The reason I've written 2a here is to kind of break up Module 2 into two separate pieces, 2a and 2b, because multiplying matrices is pretty difficult and takes a long time to explain properly and well, so I might not have enough time to do it all in one session. So, okay. Here we go. Now, before I start multiplication, I think going through a bit of algebra matrices would be very important. I'll have a separate session, episode, module, whatever you want to call it, on algebra, but on matrix algebra. But here's just a very simple kind of look into it. A and B equals C. Now we've already seen in the last module A plus B is C. That's fine. Now what you need to know about matrices with algebra is that when a matrix is written or denoted as a letter, it's always capital, always capitalized. Right? Now A plus B is equal, so wait, let's do it like this. With a matrix, A plus B is equal to B plus A. Very good. Normal, right? Isn't that normal? That usually is how it goes. But when you get to multiplication, it gets a little bit more difficult. A times B, that means times, that little dot, is not equal to B times A. And we'll look at that soon. Now that's just a little bit of a just a quick introduction to algebra and to matrix, because we're going to have to be using that today. Now, like with addition and subtraction, the first thing you need to ask yourself when you're about to times matrices is it possible? With addition and subtraction, we said if the orders are the same, it's possible. If they're not, it's impossible. But with multiplication, it's a little bit more difficult than that. So we have a 2 by 1 for A, and for B we have a 1 by 3. Now, let's do this. 1 and 2. And this one would be 1, 2, 3. Awesome. Oops. Sorry, just yeah, okay, cool. Awesome. Now, let's look at this more closely. 1 and 2 times by 1, 2, 3 is equal to C. Now the first thing, as I've just said, repeating myself a bit, is it possible? Now what you need to do is that A, you need to write A, and B, you need to write B. Then you need to write their corresponding orders. Now in order to see if it's possible or not, you have to do this. Is the column of the first equal to the row of the second? If that's true, then it's possible. Awesome. If that was a 2 and that was a 3, it wouldn't be possible to do, just to make it, going blurry, make it clear. Now, on to the third thing, to predict. But can we do more? Can we predict what the order of C will be? Yes, we can. If you use this and this to determine its possibility, then use the others that are just lying around to predict. That's what you do. Bring it up and you say 2 by 3. C will be a 2 by 3. It'll have 2 rows, 3 columns. Now I'm running out of space. Whoa, going all blurry and funny. Sorry about that. Now, can't get comfortable. Okay, good. 1, 2, 1, 2, 3. Let's move on. That's what C will look like. It'll have 2 rows and 3 columns. Now what you do when you multiply something, this is possible to multiply, is you look at the row of this. Now this is very important to remember. This is where people get stuck. Look at this row, the first row across. And the only thing in it is 1. Then you look at the first column in the second. Awesome. Then you times them. 1 times 1 is 1. Right? Right? Okay, good. Then you do that. And you know that it's in this element here because this is where these two correspond. It's in the first row and it's in the first column. And where do the two correspond? In that element there. Good, let's move on. I know that can be a bit tricky, let's just see if I can repeat that. You go in the second row and you times it by this. Now, where will this one be? It'll be there. Why? Because it's in the bottom row, so it's in this row, because it's over there, and the first column. 2 by 1 is 2. Do you understand? Hope you do, because this is where it gets tricky. I'll do as many examples of this as I can. And then you go back, and you go, okay, what's 1 times 2? And where will this one be? There. Because it's in the first row, but in the second column. Let's do this. Right? It'll be in the second column. So it'll be there, and that'll be 2. 1 times 2. This 2 by 2 will be 4. So in the first row, second row, second column. And the same for number 3. 1 times 3 is 3. And 2 times 3 is 6. I know that's very tricky. It's very, very, very tricky. All I can do is use as many examples of this as I can. Remember, you do the row, the first, so you know it'll be in this row, and you do the column of the second, which is the column there. I know it's tricky to see because it's only got one column and one row, these two matrices, so it's difficult to see. And if this was bigger and this was bigger, this had more rows and more columns, different rules would apply. But I'm just showing this to you to be as easy as possible now. And in the second module, I'll show you other examples. Wait, let's just do another really quick example. Let's make this one a little bit more complicated. Let's do some friendly square matrices. You know this one. So if that's a 2 by 2 and that's a 2 by 2, they're both equal, so it's possible, and these two outsiders make this one a 2 by 2. Now this is what you do with this. First row times first column. Right? 1 times 2 is 2, right? But because you have something second in there, you have to add that on. 1 times 3 is 3. And you add it. 1 times 2 is 2. Add 3, because 1 times 3 is 3. And then 2 times 2 is 4. And 3 is 9. And 2 times 2 is 4. And 3 is 9. So the answer would be 5, 5, 13, 13. And that's really complicated. But I'll do more examples like that in 2b.